All right, so here we're supposed to use f of x to find the domain of f. And so here we have f of x is 3x. Here we have f of x is 1 over x minus 4. All right, so domain. What values of x can we use in this? Basically, we can put in any value of x into this first one. It doesn't matter what we plug in, it's going to work. And so the solution is going to be all real numbers again. Okay. And again, another way to write that would be, you could say all real numbers, or you could say from negative infinity to infinity. Oops. Infinity, and that's going to be equal to the domain. Okay, so that's two ways to write it. So anything is going to work in that one. Now in this one, is there going to be any restrictions? Well, there will be, because here, if we plug in x is equal to 4, we're going to get 0 in the denominator. And 0 in the denominator doesn't work. And so here it's going to be all real numbers except x equals 4. Okay, so that's going to be a key. And they're going to write this different ways. Here the domain of f includes all real numbers except for x cannot equal 4. Another way we could write this is we could say if we're doing it with the notation like this, we can go from negative infinity to 4, parenthesis, union, parenthesis, 4 to positive infinity. This break here means there's not going to be including 4, and so that would be another way to do it. You could just, again, x does not equal 4. It's going to be all real numbers except for that. So there's multiple ways to always represent something, and so you kind of have to pay attention to what they're asking for. All right, so here we've got three different graphs, and they give us the domain D and the range R on each one of them. Now, this one looks like it's the absolute value sign, because if we plug in 0, you get 0. Absolute value of 1 is 1. Absolute value of negative 1 is 1, and so on. And so the domain is going to be all real numbers, because it's just going to keep going on and on and on forever to the left, and on and on and on to forever to the left and right, I should say. And so all real numbers, okay? Now, y though, it's going to be equal to 0 or greater than. So r is going to be y is greater than or equal to 0. So those are what our range and domain are. Now here, looks like our domain is going to be, again, all real numbers, x and y, or x going positive and negative each direction. We're going to get all the real numbers. Again, with this one, this is x squared. Oh, I guess I give you values here. I didn't even see that. With x squared, we are starting at 0 again and going up. So it's only going to be y greater than or equal to 0. Now here we've got the square root function. And so here our domain is not going to be equal to the whole set of real numbers, because we can't take a square root of a negative. We can get an imaginary number out of it if we put a negative in, but we're looking at only the real numbers, not the imaginaries. And so therefore our domain is going to be from x equals 0 on up. And so we're going to have greater than or equal to 0. And because of that, y's are going to be greater than or equal to 0 as well. All right. So here we're supposed to determine whether the table of values represents a function. Now remember, what did we say? It's exactly 1. So if we look at a diagram, it goes 1 to 1. No matter how we do it, it's 1 to 1. So 2 goes to negative 6, okay. 3 goes to 4. 4 goes to 2. 3 goes to negative 1. Well, that's saying basically that. So we could take that off and say, well, 3 is going to 4 and negative 1. So that's going to 2. So this shouldn't be a function. And so it doesn't represent a function, because x equals 3 produces both a 4 and a negative 1. Hence, it's not a function. Okay. Now, another way we can do that is with the vertical line test. So what we could do is we could graph this. Remember, this is going to be our y values. That's going to be our x values. We could graph a table and make it x, y intercepts and all that good stuff. And so if every vertical line intersects a graph at no more than 1 point, then the graph represents a function. Okay. So if we look at these two graphs, no matter how many times we draw a vertical line, it's only going to intersect at once here. So this will be a function. Now, the first time we draw a line here, boom, we hit it twice. Well, it's not a very straight line because I can't draw straight, but that's okay. And so this is, no, it's not a function. Okay. Now, if we would have drawn this one, that'd have been hard to do, but somehow it would have, we would have something where it's going to have two things. It's going to hit at this is at 3, and it's going to hit at the 4 up here, and it's also going to hit at the -1 down here. So it's doing something weird, and so it's not going to work at that point. Okay. All right, so that's our determining how it works. Vertical lines, only 1 point, it is a function. 2 points, not a function. All right, so again, same thing as what it says here. So that's a nice thing you can do. And you can see they have a nice vertical line here, so it works very nice. And here, no matter where you do it, it's not. All right, so that's all I have for this section. Hopefully that helps.